everybody. Good morning, good evening, good afternoon. Greetings to you wherever you are. Mark Miller here. Rory looks like he's not with us today. I don't blame him. It is the day after Christmas, so he's probably taking a break. I'm also just noticing. Looks like I'm slightly out of focus here, and on top of that, I've got reflection in my glasses, which are probably not going to be able to adjust here for this with these lights. So at any rate, those are my morning distractions. My check-in is I'm actually kind of interested in pretty interested in what we're going to do today. We're going to build a particle system. And I'm looking forward to that. Looking forward to seeing how that turns out. When I say particle system, basically it's going to put little particles on the screen and give them properties to make them look like sparks or like smoke, that sort of thing. So that's what we're going to build. The foundation for this, let me show you, give you a sense of that. Let me bring some. Kind of bring up my design spec over here. Let's do this, I think. To this right here. We'll just bring this up here on the screen like that. And so this is for a Dungeons and Dragons based live Twitch stream that I'm planning on doing here in the hopefully near future. And you can see here that I've got the screen divided into a game board for the Dungeons and Dragons. The players are over here, Dungeon Master's up here, and then down here we've got the chat gameplay area, and down in here we've got the actual players. And so folks from the chat room can come in and be a player, and they can battle monsters, that sort of thing, using commands from the chat room. So all of that is pretty cool. One of the player types is a wizard, and the wizard looks like this, right here. And one of the animations the wizard has is this, and the wizard's essentially going to wave his wand, and when he does that, I want particles to come shooting out of there to make it look like a magical effect. And so that's kind of the goal here of what we're going to try to do here today, is build a particle system. And so in anticipation of all of that, let's go over, let's take a look at what we've got checked in here for today. You can look at the source code. I'll put this in the chat room. Right there. Yeah, well, then it says Boxing Day for Rory. Is it Boxing Day today? What fun. Here's my source code right here. And episode 67 begin. I've just checked this in moments ago. That source code contains minor changes and 3 new empty files. I've got vector, emitter, and particle. And as I've been giving this some thought, oh, hold on one second. Karen, since you're right there, can you take that light that's facing me, and on the back of it, there are 2 knobs. Drop them down. The brightness is too much there. There we go. That's perfect. Thank you. Much better. All right. So the vector, I think, is going to be needed as we are doing some of the math here. We're going to do some polar to Cartesian conversion. So we're doing some high school math today. And we'll need that because we'll need to have particles shooting out from a single point, and they'll kind of shoot out in kind of a spread of random directions is kind of the idea. We're going to have the particles themselves. Those will shoot out and be able to track themselves where they go. They'll be able to be affected by gravity. Maybe we'll add the ability to affect them by wind as well. We'll see what we need in terms of the look of this. But the particle's there. It'll have a lifetime. It'll have a size available to it. And even those things can change over time. So I want to be able to, I think, ultimately add keyframes as well to this. So I can say I want to animate from this state to that. So I can even have the particles change color, that sort of thing, or change size, change opacity over time. And the emitter is the place from which the particles shoot out from. And the emitter can have a size to it and like a radius. And it can also have things like a velocity and in X and Y directions. And that velocity can be also, its motion can be impacted by gravity as well. So we can kind of shoot something up and it can have sparks. You can also use this for, like, for example, an archer could shoot an arrow that would be a flaming arrow, and you could use this to create that flaming arrow. WorldWake says, yes, Karen, turn them. Just kidding. And WorldWake says hi as well. Karen's left the room. Sorry about that. Will Bennett says, got busy, so didn't get you a Christmas present. But, you know, Will, you've given us so much in the past. We're feeling more than, more than appreciated. So thank you so much for that. He says, but here's a little GIF. Link, rel, icon, href data. That will remove the Chrome message about fav icon not found. Oh. All right, let's do that. I think he's talking about on our, let's see if I can see it here. Where is... Where is our test run of, not there, not there, not there. I don't see it. Right, wait, here it is. There it is right there. Okay. So I think he's talking about this piece right here, fav icon not found. And I'm not sure, is that showing up in the console? I'm not sure where that is, where that message is shown up. Oh, look, we've got some messages we're sending out here. We also have this right here. It looks like I lost a splat sound here, so I need to go find that. Second since first collection. So we've got some console log messages. Let's go find those and clean those up. Console.log. Looks like they're here. Kill those. And what else did we find here? Find results. I don't think we need that anymore. That one I'm going to comment out because I kind of liked the data that we were sending there. Let's clear that out. Comment that. Comment that. No, kill that. We don't need that anymore. All right, that one's commented already. Show hit. Interesting. Okay, I'll keep that as it is. Log state, I'll keep that one. And we'll comment that out. Okay, so just cleaning that up a bit. Let's take a look at this. Here's a little gift. Link, rel, icon, href, data. I think he wants that. Well, tell me if this is what you're talking about here. I think we want it in pages, the page that we're testing from. And I think you're talking about putting it like up here somewhere, like maybe there. That's what I'm thinking. When you refresh the browser, it should show up. You're talking about here, right? If I do a refresh, you're saying I should get the message when I refresh the browser. Let's see what happens. Yes, in the console. So we got the, yeah, our sound effects splat.mp3 is gone. We'll have to find that and get that back. I'm not going to do that during the show. Still loading. Still loading. I think I want to change that too. I was thinking about fixing this up so it would load faster. So I think maybe we fix it. There's no error, there's no message here. If that's what you're talking about, it looks like maybe that's the case. You put the snippet in, so it should not show up if it was in the right place. I put it in the head section on mine. And what did we do? I am not familiar with CSHTML, so I can't tell if I'm in the head section or not. But it looks like, yeah, I'm going to say maybe it worked. So see what you think about that. Well, you can tell me. All right. All right, so let's kind of talk about the particle system and take a look at what we're going to build here. I think I want to work on the vector a little bit. Let's just start kind of filling out these classes a little bit. And we'll add some properties and things that we think belong there. Let me switch over this view so we've got a little bit more code, and let's start building some things here. So we're going to call this a vector, and I think it's going to have my standard vector. I think it's going to work with Cartesian coordinates first. So I think what I'm going to do is create an x that we're going to pass in, and a y that we're going to pass in, and I think I'm going to make these both public, like that. And so those will become properties x and y, and then I think I want another function in here called from polar, I think. And then I want to come in here and I want to say degrees. I think I'll work with degrees instead of radians, and a distance, like this. This is going to be a number as well, like that. And what this is going to do is this is going to create a new vector and return it, like that. So we're going to need to do some conversion, some math here, which I have no recollection of what that math is going to look like. So let's see if we can find some polar or rectangular to polar conversion. Actually, I want the other. I guess I want polar to rectangular conversion. And I think I should probably specify degrees as well. Math is fun. Okay, cool. Converting between. Well, oh, they are talking about degrees in here. Let's see where we are. No, no, no. I like the first answer that I was getting before. Oh, here we go. That's kind of what I was looking for, right there. So let's just put that in there. So we've got that as our reference. And so our x is going to be our distance. And I think theta in this case is not, this is the part that I think has always been, that's never really stuck with me. Cosine, it's actually doing cosine of 195 degrees right here in sine. For some reason, I'm remembering these as we had to convert them first from radians to it. Let's see what's going on here. WorldWake is asking, you want a mapping from xy to r theta? Yeah, that's essentially what I'm doing. Well, then it says you would consider making this an immutable class, save you some headaches later. Okay, we can. I think we can work to do that. This vector is new. Vector, this radius times math dot cosine this dot radians. Yeah, that's what I'm thinking. It's in radians is what I think it is. It's radians coming in, but I want to kind of convert from. I think I want to work from the outside. It's in degrees. That's what I think I want to do because from a standpoint of just client using it, I want to be able to do that. So I think from polar, I'm going to come in degrees. So maybe we'll, so we have some ideas here. So let's take a look at some of the code that Will's given us here. I think I want to, I think it is fair to say, all right, let's convert degrees to radians first, and then we'll do that. So let's get that in there. I think it's something like divide by 2 pi or something like that, degrees to radians. Conversion times pi over 180. 1 degree times pi over 180. Okay. So equals degrees times math dot pi divided by 180. Okay, so that would be our radians right there. If we want to store that and keep that, and I guess that is making sense. I just want to make sure that if I modify one, I modify the others as well. That's what I want to do. Okay, so I'm going to instead declare radians as a number is what I'm going to do. And whoops, I wrote degrees, but I meant radians. And I'm going to set that equal to this. I'm just going to make it local for right now. So right now I'm only going to store x and y here for the vector, and but I'm going to do this calculation internally right here. Excellent. Well, you came out and helped me as well. Degrees to radians is equal to just what we had right there. So degrees times math.pi divided by 180. So excellent. So we've got our radians here. And now we're going to say this is the distance. And I'll make some modifications to this if we, as we need them. So I'm not really sure exactly how. I have a sense that I'm going to need to get x and y, but I'm not so sure that I'm going to need to always know my radians, that sort of thing, and my distance. And this is going to be distance as well, like that. And then that's just going to be a return of it. I think I'll keep this comment here because I like it. And we're going to return this like this. Now, now one of the suggestions that needs to be a static method. Yeah, it absolutely does. Thank you. Okay. So one of the suggestions Will had is to make this an immutable class, which is kind of interesting. To keep from getting in trouble later. I am not 100% on board with that yet. I kind of get it, but I also am like, well, I'm not sure if I want to be able to mutate it and have it be able to kind of update itself as well. So I'm not 100% sure yet. So I'm going to kind of put that choice on hold for right now, and we'll come back to that later. I think what we'll do. But now we've got it. Now we've got a vector out there, and I think that the and the way I was imagining this is that I could modify this location and come back later and maybe ask it questions like, what's your new degrees, what's your distance? But let's see how we need it first. So that's just going to be the first work that we do there for that. The next piece is I think the particle. That's the next piece to work on right here. And so let's create the particle class like that. And so the particle, I think, is going to have an XY position as well. And I think those are going to be, we're going to initialize it, like say here, you're starting here. I'm wondering does it need to reference the emitter? And I'm going to say it does not. So let's go in here, and actually we can save a little bit of time because we can copy just this code right here, because we definitely want that for the particle, I think. I think we want a radius. I'm going to just paste this in and change some of these because a lot of these are numbers here. I think we're going to say we want a radius. I think we want an opacity. And I think we want a color. Or maybe I'm wondering if I should use the components of color, like a hue, a saturation, and a lightness to it. And let's do this. Let's say public, whoops. Let's go down to the next line here. Color. And I think we're going to do that. So that'll be the particle. Particle will have a position in space and time. It'll have a size. It'll have an opacity. I think later too, I want to be able to have particles be able to link to a sprites collection, like for example, some different clouds or smoke pictures, and then have those, have it iterate through those so we can show smoke trails that are kind of moving as it moves through. But for now, we're going to just draw these as circles. So particle can do that. I think we've got a draw function inside of here. Like that. It's going to take a variable of type context, of type canvas rendering context 2D. And I think it's going to have a time in here as well, called now. And I think we might have an update position as well, piece inside of here, I think. Or we have the emitter control this, because the emitter is going to own all the particles. Will says you can specify the components when you pass the color, like RGB 1, 2, 3, I believe is the syntax. You can also do RGBA and HSL if I'm not mistaken. So interesting. So we created our own HueSat light class for some of the other work that we were doing. Whoops, that's the JavaScript one, but the TypeScript one is, it's out here in the game engine right here. There it is right there. So we created this class before a while ago, and it has some nice features like from hex and things like that in there, and from RGB. So so I think we are kind of in sync with, we have what we already need with what Will is suggesting, I believe. Okay, back over here. I think we're going to have an update position where it's going to figure out what it's going to do based on gravity and that sort of thing. I think I need a this.last update time, so I can calculate the distance in time between this time point and the last point. So last update time is equal to, and I'm going to pass in now. I've got to pass in now. So let's pass in now early on, like right here. Now. And let's set some default values here. So if we specify no radius, it's just going to be a radius of 1, so a little pinpoint. We'll set opacity at 1, and you set light equal. I think we can do a dot from RGB, from hex, and we'll pass in white. Like that. Let's just double check that our from hex doesn't need a hex code at the beginning of it. Looks like it does. Don't see that as an optional if I'm looking at that right there. Okay, so we'll come back and put that right there. Okay. Last update time is equal to now. Declare that property up there. We also need a velocity as well. And I'm going to add these also as properties that'll have some defaults. I'll put them here and here. And velocity x, that's going to be equal to, I'll default it to 0, and velocity y as well, that we'll put right here. And that's going to also default to 0. Okay, so we have basically, we can initialize with just an x, y, and a time. And that feels like we've got kind of the structure for the particle. We haven't implemented any of these pieces yet, but we can get there soon. And I think I want to move on to the emitter soon. Hold on a second. It's optional. Is there a question mark after the pound sign? Did I see that? I didn't notice that, but maybe that was there. Let's see. Oh, you're right. It is optional. It is totally optional. That was the piece I was looking for 2 different ors, but looks like it is optional. So we'll take that out. And just to verify that, we're looking for red particles now, F00. Okay, next our emitter. Our emitter is going to have a whole bunch of particles, so let's build that. And that's going to have an X and Y position. That's going to have a whole bunch of particles. So I think I can do, there's a template in here, new array of, oh, but I don't have, hold on, I'll make a new, can I do that? No, what is it? VA.n, is that going to work? That's going to get me close to what I want, but I'm going to change that to particle, get rid of that. And am I done? Is that the correct syntax? I think that is. So this is going to be our particles. Just an array of particles. And I think I can come in here and just say new. Let's copy it. Array of particles, like that. And this is kind of similar to particle in that it's going to have these, and also it's going to have a velocity as well. So the emitter is going to have a velocity and an XY position in a time, and it's going to be moving. What do we got here? Sorry about that, Will. What do you got here? Oh, wow. Look at that. That's Gia saying, what's up, what's up, what's up, what's up? Why not specify position and velocity as a vector? Because I'm scared to do that, Will. I'm feeling like I'm comfortable dealing with rectangles and scared dealing with vectors. Should I do it, Will? Is that what I should do? Should I go into the scare zone, the zone that I'm afraid of? I feel like I'm doing this because my physics engine is working with X and Y's as well, right? And so part of it is I feel like, well, I'm going to have to modify my physics engine if I do that, maybe. I don't know. Yeah, that's kind of where I'm at right now, Will. And I'm like, I'm doing it based on comfort. I feel like I've got known entity here, and I feel like if I go in the unknown entity, we might get into a position where I'm trying to struggle through something and nobody wants to watch me struggle stuff. You can use the components separately if you are scared. Just use the vector to bundle them without doing any vector math. Okay, Will is saying let's do vectors. So Will, I'm gonna go ahead and say we'll jump in and we'll do that. So let's look at that then. Oh, I think I know what you're talking about. Wait, actually, what you're suggesting is actually pretty simple. I think what you're saying is throw the vector here and have it be for particle, I think, as well. This is what I think you're saying right here. You're saying instead of having an x and y, just have it call it position, I guess, or something along those lines. And I always think of vectors as, I think part of the thing here too is I'm always thinking of vectors as a transition between one point and another. But arguably, if the one point is the origin, then it's the same thing as a position. So I think this may be closer to what you're suggesting, right, like that. And if that's what you're suggesting, then yeah, I absolutely am fine with that. I agree with that. At which point, we also means our velocity becomes a vector as well. Right, to simplify it. If that is your suggestion, I'm absolutely in agreement right here. Velocity, like that. Okay? Okay, so now we've got position as a vector and velocity as a vector. I'm feeling pretty good about that. Will, give me a comment over there. Will's saying yeah, so it sounds like that's the right, what he wants to do. So I'm good and happy with that. Let's now take those pieces right there, come back out here. Actually, it's just occurring to me that the radius, hold on. Yeah, the radius for the particle, we also have a radius. I think all of these are part of the emitter. But I'm going to show you how it changes here. So I'm actually going to take all of those and give them to the emitter as well. So now we've got a position, we've got a time, we've got a velocity vector, which is equal to, let's give that a new, I forgot to give that a default. So vector dot from polar, and I think I'm just going to go do 0, 0, right, like that, as my default. Let's put this over on the particle as well. Okay. And did I get all of the HughSat light? Yeah, I did. Okay, and so now we've got a position, the time that comes in, and let's go in here and say, let's do the same thing here with the update time. I think we need that. Okay, and then we're also similarly going to need draw and update positions. Let's go over here. And then we want like a for each down here for all of the particles inside of here. Particles for each, and it's going to be item of type particle. Whoops. Particle, like that. And I think this is the binding piece right here, and I think I want to do that. So it's this dot particles for each. That's this argument there, and I'm not sure if is that right, or I can't do that. No, I don't. I'm not going to do that because that's going to. I think that this is already going to be for the particle when I come in here. And so now I want to come down here and I want to say particle.update position, passing in context and now. Like that. So there's that piece, and then the draw comes in here like this, particle.draw, like that, getting context and now. Okay. Technically, vectors are direction and magnitude, but you can just use it to represent points, is what Will says. Yeah, that's the piece I decided to become comfortable with, right? So yeah, but normally when I think of vector, for me the meaning is always transition from one point to another. So I think that's what my stumbling block was. So there's my emitter. So in update position, we're going to call update position for the pieces, but we also need to create. We need to create them. And one of the other things we need to do here is we need to, there are more properties to this. There are kinds of, I feel like what we almost need is a almost need a second class, but we could put everything in here. And the idea is that we would create this and then modify the other pieces. In fact, we could arguably, Anonymous is now following. Okay, excellent. Glad you're following Anonymous. Let's see here. I'm thinking arguably we could take these out of the constructor to make it a little simpler. Yeah. Let's take these out of this constructor here and initialize them locally though. And we'll say this radius is going to be 10 instead of 1. This dot opacity is going to be equal to 1. And this dot color is equal to that right there, I think. Let's declare these. Can I declare that? There we go. But I want to have other properties too. And one of the properties I want to have is variance. So I want to be able to come in and say something like, let's also do this. Particle radius. So I want to be able to set what that particle radius is. And then when I create a particle, I want to be able to vary it as well. And let's show you that. So let's come in here. We'll declare the property particle radius. And then I want to create a second property called particle radius variance. And that is, I'm going to set that equal to 0. So that means every particle will be exactly 1. And so think of this in, whoops, this should be variance right here. And so that means there will be no variance. But if I make this 100, that means my particle will go from something close to 0 to all the way up to 2. So it'll go between, it's basically plus or minus 100%. And if I make this 0.1, then it'll go between 0.9 and 1.1. So that's what's going on there. Okay, so I'm going to say 0 for that. Hold on one second here. I want to check something. I want to try something out, by the way. I created a new layout here, CG2, and let's see what happens. Oh, yeah. So take a look at that. Hold on one second. All right, sorry about that. I was just, it looks like I lost that. Hold on a second, it's going to load back up again. I had to blow my nose. I want to make sure that wasn't out there. Let me do that, bring that test up again after we're done loading here. CG2. And run it. Oh, we disappeared again on that second one. Hold on one second, I'm going to switch. I'm going to have to fix that in a second, I think. I need the overlay bot to move over to that one. Uh-oh. Copy. Give me 1 second here. Okay, I think I've got that fixed. All right, okay, so I want to start getting to a point where we're drawing and we're actually emitting these particles and putting them out. So we need that. We need also to have, we need some property that's going to be particles per second. Like that. And we'll say something like, I don't know, like 100, 500. So that's how many particles we're going to pop out per second. And whatever that rate is, every time we update, we're going to see how much time has passed, figure out how many particles we should put out, put those particles out. And then we'll shoot them out in kind of random directions, but they'll take on whatever velocity we have. So if I shoot the emitter across the screen, we'll have particles coming out from the emitter that'll also have that same velocity and will similarly be affected by gravity. If this one is, I think we need to have a sense of what the accelerating forces are on this from some place here. I think I want to do this. I want to create a new emitter. Let's go over to our main in our CodeRushed game and our drone game, actually right over here. And let's create a new emitter. Like that. Load resources. I guess I can throw this right up here. So emitter equals new emitter. Like that. Emitter is going to take a vector on this. So what I want to do is I want to say, I think I want to add a from Cartesian like that. And I want to pass in center, screen center X and screen center Y like that. And pass in a now time to it as well. Do I have now at this point? I don't think I do. That's a this right there. I need to declare this piece. Let's go in here from Cartesian. And I you know, maybe I should just say NoVector instead of from Cartesian. Yeah, I think I'm going to do that instead. NoVector. And okay, let's see. Load resources. Initialize. Where's my performance.now call? Is that passed in? I bet it's passed in. Hold on, let's see where it's passed in. It's an update screen. Yeah, I'm kind of feeling that we want to change, at least start to that. No, I don't want to do that. Where was it was in load resources. I think I was right in here. So it looks like I'm never actually giving it a now from the initialization. And I guess, so the question is, do I want to give it a now, or do I want to reevaluate whether the emitter needs to have a now passed into it, as well as the constructor for the other pieces? Maybe the answer is I don't need those. Yeah, from Cartesian is just the NoVector. Missed the semicolon on the emitter property declaration. Did I do that? Yep, I sure did. Let's get that in there. So I'm trying to avoid having performance on now calls inside here is what I'm trying to do. And I think that I'm starting to look at that. Let's find our way outside to that load resources call. Yeah, it feels to me like time doesn't matter on load resources. Time shouldn't matter on initialize, but start, time should matter. That's what I'm thinking. I think start should get that. So if that's the case, I should be able to create, if I'm following that logic, I should be able to create a new emitter without telling it what time it is. And later say, okay, here we're going, it's the go time now. So I'm gonna, I think, take that out of there and come back in here as well. And then the question is, what am I going to do with that? Am I taking it out? I think I'm taking it out. And let's do this. Let's do that. We're going to have to do a check on last update time to see if it's been initialized or not. If we need to reference it, but I think that's what I'm going to do for now. Okay, then it would also similarly make sense that for particle we do the same changes. So we take out now from here, and we're going to say last update time is equal to now after we do the work here. And then we end with that. Okay, back to emitter. Actually, back to drone game. So there it is. So we've done that. Then we're going to say emitter dot, and let's actually, I think we're okay there. I think we're okay there with just that. Then I want to go to update screen, and I want to say this.emitter.draw, passing in my context and now, and up above I want to say this.emitter.update position. Oh wait, do I have? Yeah, that's exactly what I want to do. So we'll do that. We'll put it up in front of my rocket. And then we're going to call update position of now. Okay. So now we are drawing, what's wrong? Why is that not working? What's my error? Expected 2 arguments. Of course. Oh, wait. Not, of course. We do not need a context to update the position. Yep, you got it. Will Bennett said context, I think. Yep, that's exactly right. All right, so that's feeling better to me. So now we've got the update position there. So now what I want to do for emitters, I just want to get something on the screen so I can see it. And so we're not going to have any particles initially. I just want to come in here and I just want to say, let's draw a... or let's do this. Let's add 1 particle for now as a test. So we'll say particles dot add, or push, I think it's going to be this dot particles dot push. We're going to say new particle, and then we're going to say a new vector for the position. And the position is going to be our position, this dot position. Oh, wait, I can just pass in this position. And I'm getting a feeling this is where the immutable suggestion is going to make sense to move in that direction, but yeah. We'll say the same thing. This is where you get into trouble if I pass this position in. Okay, so, but if I make it immutable, I'm not in trouble. So, yeah. No, I get you. Yeah. Okay. I'm aware of it. We got it. We'll keep going here on this. And the velocity is going to be this dot velocity as well. The radius is going to be the particle radius, or maybe we'll say, let's do this. Let's put this in a function called add particle. So we can kind of put this out on a couple different lines here. And let's figure out the radius. So we're going to say radius. You can add a clone method. I know I was thinking the same thing, but it keeps getting messier. Yeah. Okay, I'm trusting you. Yeah, I was totally thinking the same thing. Clone but I was thinking the same thing. It was going to get messier. Normally you would do x equals x plus 1 because that's because number is immutable. X equals x. I'm not following that. Normally you would do x equals x plus 1. I'm totally not following that well. I'm looking at your comment and totally blanking out. So anyway, we're going to say particle radius. Let me write this code and I'll come back to it. If you weren't using a vector. Oh, yes. Right. I think I'm with you. Okay, hold on. Particle radius. So this is the new radius of the new particle we're going to create. That's going to be equal to this dot particle radius. Then we've got to figure out our variance to see what that is. And see how that impacts it. So if our variance is greater than 0, if the particle radius variance is greater than 0, then we need to do something here, and we need to say that particle radius is equal to that plus this distance, this variance, which is going to be a percentage. It's going to be a percentage times, it's going to be a percentage, and it's going to go between 0 and that. So we need a math.random in here. So it's going to be math.random times, and I think it's, yeah, just like that. This is going to be a number between 0 and 1 times my variance, I believe, plus 1 if I'm figuring this all out. So if my variance is essentially 10%, then I'm going to add 1 to it to get 110%. There's my random number, but I want to actually go plus or minus by the 10%, I think, right? 10% up or down. So if it's 0.2, then 0.1, then I really want to go to 0.2. So it's going to be 2 times this, right there, minus that variance again, plus 1, I think. So let's just throw in a couple numbers. Let's say the variance is 100%, so it's a 1, like that. If that particle variance is 100%, then I'm going to take my random number, multiply it by essentially now 2 by that. So it's, and if my radius was, let's say it was 100, let's just change these numbers so we can see them all on screen here like this. I'll change them back to this, but I'll bring them right down here. So we're kind of going to say, what if it was like this? Then we're coming in here, we're going to say our particle radius, wait, I've got to multiply this thing by our particle radius, I think, at this time. So if we say the particle radius is 100, boom. Particle radius variance is 1, which is 100%, which means it can go from now 0 to 200. All right, with those two numbers, we want particles between 0 and 100 and 200. So that means we're going to come in here and we're going to say particle radius, which is already 100, is going to be that plus the random number, which is going to be 0 to 2 now, times the particle radius variance, which is a 1. Okay, so we're going to get 0 to 2, minus particle radius variance, which is going to be getting now numbers from -1 to 1. Plus 1, which now we're back to 0 to 2, times particle radius. 0 to 2. Is that right? No, I think I've got too much in here. Math.floor, math.min random. Hold on. Math.floor of math random times max minus min plus min. Right, that's to get me basically a between. Right there. No floor if not an int. Let's paste that in there right there. Yeah, in fact, yeah, let's do that. Let's do this for right now because I think it's gonna be easier to if we do this. Between, we're gonna create just a function here temporarily. We'll probably move it somewhere else later, but we'll say here's my min, and here's my max, like this, and then we're gonna come in here and this is gonna return a number. Speaking of which, this add particle is going to return a void. I think maybe it'll return a particle later. This will definitely be a void, and this is going to be a void as well. Okay, so this is now going to come in here, and this is going to say return. And this we'll call this random between, like that. So I think this is going to be a little bit easier. So if that's the case, then we're going to say particle radius is equal to, and we're going to say this dot random between, and whoops, and that's going to be between our min value, which is now going to be our particle radius minus, well, let's do this. Let's create a variable up here, which is going to be our distance, maybe. Our range, half range. Call it half range. Like that. And that half range is going to be equal to our particle radius times our variance. Right, like that. So particle radius, so if the variance is a 0.1, that's 10%. So particle radius is 100. That means this is going to be, our half range is going to be 10. So we're then going to subtract 10 or add 10 to our particle radius. So that's going to be, our min is going to be there, and our max is going to be here. And I think we get code that's easier to read too, like that. Lost this Twitch stream, had to refresh, missed the last 10 seconds due to commercials. It was like the most awesome 10 seconds. Actually, I was kind of, finding my way here. Added the random between function up above, right there, based on the chat room suggestion you gave us, Will. And I kind of broke things down. I was trying to do something all in one line of code, and I broke it down into smaller bits, and I think it's better. So now we've got basically what we've done. We've got a random between call right here, which gives me a random number between the max and the min. And so we've got a math, basically the code here is the random number 0 to 1 times my delta plus the min value. And that works as long as max is greater than min, like that. This random between, particle radius minus half range to particle radius plus half range. And that's my new particle radius that we get right there. So we can get rid of that. Right there. The max is exclusive. For inclusive, we're going to change that. I think I'm feeling pretty good about where we are with that. Max minus min plus 1 is what you're doing. You're basically saying adding 1 to that delta. That doesn't look right to me, the math floor call there that you've written out. Yeah, I don't think it's plus 1, because these could be any set of numbers that are out there. Math.random is an exclusive one. I know, I get that. I totally get that. but it's incredibly close, right? So hold on, got a link out here. Let's check that out. Yeah, where's the, here it is right here. Okay, is this max minus min? Oh, this works, I think, because we're dealing with ints and we're rounding down. That's why the +1 works there, but I am not dealing with ints. This, I'm pretty sure, is not going to work for us. Yeah, this is, I think, definitely not going to work for us at all, because max and min could be any set of numbers. They could be like 237 and 592. So that plus, yeah. So, but even omitting the ceiling and floor calls, it's not, this +1 only works for ints. The +1 works because it's basically just getting us over the top there so that we can come back and round it down. It's not going to work for not ints. And I am definitely using this in a floating point kind of way. So, yeah, I'm gonna, and I'm okay. I don't need it to be inclusive of the max number, because from my perspective, a point, 0.99999, that's essentially inclusive of the 1. So I'm okay with that. Okay, so back down here. So we've got our particle radius now, and I believe we've got code that successfully is using the particle radiance variance. So depending on what that is, that's going to give us a bunch of different particles of different sizes. And then we're going to, so there's my add particle call, and now I want to push it. And what you got now for me? So get rid of math floor and random between. Oh, you're right. Perfect. Good. That's what I want. Okay. All right. So let's see. Math particles push, new particle, this position, this velocity. And we've got the radius, and we're going to pass in the new calculated particle radius, like that. We'll keep with the default opacities there. So that's good. And let's also add a distance variance, I think is what I want to, well, it's within the radius. We've got a radius in the emitter already built in. So the radius for the emitter tells us how far away from here that we want to go. And I'm now on board totally with making this thing immutable. So let's figure out how we do that, because I actually don't know how to do that. So let's see. Immutable TypeScript. See what we get here. It's just read only. That's simple. Okay, gotcha. All right, so it's got to be right here, right? Read only. There we go. I used the RO template in CodeRushed to get that. And since we're not doing storing anything else, I think we're good with those pieces right there. And so, okay, so now what I want to do, I think I also want to, have an add function in here, because I don't think there's operator overloads in TypeScript, right? I would be really surprised if there are operator overloading in TypeScript. Yeah, why not? I believe that's absolutely true. Okay, so I want to have an add function inside of here. And I want to bring in a vector right here, like that. And that's going to return a new vector coming back here, I think. And I think the new vector is simply going to be return new vector, and we're going to pass in this dot x plus vector dot x, whoops, dot x, comma, this dot y plus vector dot y, like that. And there's our add. Okay. All right. So there's our add function inside of there. So what I want to do now is I want to come in and I want to say for the XY position, instead of saying putting the position right where the emitter is, I want to put it somewhere outside. So I want to say the position dot add, and I want to say vector, and here's where the degrees kind of thing, the from polar call is I think going to be useful. And we're going to say degrees, and I guess I can just call this dot random between, or I could just, is it going to be faster, fewer lines of code, between 0 and 360, like that, and the distance is going to be, yeah, let's do this instead. I'm going to say random and give it a max. Let's create a new class. I'm ready. Create a new class, call it random. And I don't think I need a constructor. We'll have this between, gives me that, and random dot 2. Up to, like this. Max, yeah, I like it better. And class random, duplicate identifier random. Ooh, do I already have a class called random out here in my game engine? I do. I may already have these things out here. Cool. These were written like months ago. Okay. We're going to change this to be int between, like that, and change this to be int max. And then we'll put these other pieces inside of here. And so we'll just have between and max and make those static. Okay, that feels a little bit better to me. So we've got that, and now we're going to come in here and say random dot between, and that takes care of that. This one's going to be random dot max 360. Better already, feeling better already on that from polar. Then the next piece is going to be this dot radius right here. So it'll shoot out in some angle from where we are, and we're adding it to our current position. So the vector, all of that should work, I think, if we're geniuses. And if it doesn't work, you know, we still could be geniuses, I suppose. So let's see what I've got here. Let's see, new particle. Let's take this. Is that my position? Vector from polar. Looks like I have got a paren problem here. Position dot add, and that's what I need right there. Okay, so I'm going to take this out, And I'm going to call this my new position right here. And so particle position, like that. That's actually going to be a vector. That's going to be equal to this. And the velocity is going to match our velocity as well. And also, though, the velocity, to some degree, it's kind of a reflection of its position, its starting position. And I think, or alternatively, we could just say it's, I'm going to, for right now, just keep it like this, but I'm going to put a to-do here. And I'm going to say, consider ensuring velocity is along same vector as not this velocity, but as this piece right here. This part of the vector is equal to, and this is going to be our offset, like that, like that. And so we want the velocities along the same vector as offset. So that if I've got my center of my emitter here, and my emitter has a radius of 10, and I say, well, I'm going to start my particle here, right? Because it has a variance, right? Well, when it goes there, I don't want it coming down. I want it going, out, kind of shooting out from it. So I kind of want all of these, the velocities of all of these to kind of go out over time. I want to get to a point where we're actually drawing something now, but I feel like we're close to it. So we are now, look at this line, particles.push, and creating a new particle at our position, giving our current velocity, and the particle radius, which we've calculated already based on the variance. And I think that looks like that's good. So so that's our add particle. Now I want to come in and I want to say, I think I want another function called add particles, which is going to take a number. And then I just want to have a simple for loop here. And inside of here, I want to call add particle, like that. And then I want to put in my draw function for so we've got update position, we've got draw. This should already be being called. Why is this not called in the emitter? Let's look at this. I'm doing tab to next reference here on the emitter. I don't understand that. Let's go back into the drone game. Oh, I think I wonder if it's, actually it may not be this, but let's go. There's something else I realize I have to fix anyway. In that in my pages, I need to come over here and I need to reference those pieces here. And I can't do it while I'm running, or well, wait, maybe I can. It's allowing me to make changes here. So let's put some of these in here, and we'll say, we're going to say vector. We need that. We need particle. And we need the emitter. So those will be certainly helpful. Over in drone game, we've got a call to draw, we've a call to update position. So good, particle draw. And now what I want to do is draw that circle. And as I recall, drawing circles in TypeScript is this weird thing where there's not an ellipse. Draw a circle. I have to do it as a arc call. It's a little bizarre, but okay, we can do that. And yep, context.arc. ZerkBTW says, hey man. Scappy Madness says, hello, I'm a new programmer. I've worked for EA, Google, Microsoft. I believe there's a way to optimize your program by using infinite Recursion, that sounds awesome. Like we can call a method an infinite amount of times. That's perfect. I love it. Nothing could go wrong. Okay, so let's just copy this. And it is basically, we have got a call to begin path. And the arc is the X and Y position. So we're going to say our position dot X. This is going to be position dot Y. The radius is going to be, I think I've got a radius. Yep, I do. Radius is there. And my starting angle is going to be 0, and we're going to end with 2 pi. Let's do something like this. Ending radius. No, ending arc. Ending angle. That. And I'm assuming that this is going to not recompile every time it's not going to be executed. Thanks. I like it better. 2 pi. Fine. There we go. 2 pi. I'm assuming this is going to be optimized, that it's not going to come in and calculate this every single time. What else? I put that in a math EX class, is the 2 pi part. Oh, I kind of like that. Fine, fine, fine. I like it. That's a really good idea. Let's go throw it out near random, because it's kind of similar in terms of kind of what's out there. I guess you could also argue it's kind of also, let's do this. Class math, like this, math EX. And it's going to be static, read only. And I think that's what we do there. Yep. Static read only. Okay. So we're going to now come in here. And I'm going to change this because I'm more like, I'm this kind of a guy right here. 2 pi, although 2 looks really weird there to me all of a sudden. Why do we spell 2 like that? I don't know. All right, so let's do this. We'll copy that. We'll come back over here. We'll say math.2pi. mathEX.2pi. Yeah, nice idea. I like it. Okay, so now we're going to do the arc. There's the radius. We've got a begin path call and the stroke call at the end. Actually, I don't want a stroke. I want a I want the fill aspect of it. Do I really have to search separately for filled circles? Fill circle. Look at this. It's just fill instead of stroke. That's it? Okay. All right. Context.fill. All right. And then we're going to need to come in and give it a fill style. Is that right? That's where we give it the color. And then we're going to say it's equal to color dot to hex, like that. And then context.fill. And I think that will do it. I think that'll do that. So let's see what we've got here. We've got let's look at our drone game. We're creating there's my emitter right there. Let's come in here and let's call a dot add particles. And let's add like 20 of those. And I think that we've got enough that if we refresh, we're going to see them drawn right in the center of the screen. And they should be red, as I recall. So let's actually come over to here. Let's try a refresh right now and see how badly we get here. See what we get. Oh, look at that. Already we're seeing them right in the center. Right there. Hard to see if the variance is working on that, but let's change things up a bit and see what we can do here. So let's come in here and let's say this dot emitter dot particle radius. Let's say they make that equal to 10. Okay, and let's say this emitter dot particle radius variance. Let's make that equal to 50%. Okay, let's also make the emitter radius, set that equal to like 80. So it's wider, it's bigger around. And let's go refresh the screen. So here we go. It's still loading, by the way, but I love that the emitter comes right in and starts drawing. It's still loading all those resources we have. So at least we get a test on that. Oh, nice. So that looks and feels pretty good to me right there. That looks and feels pretty good. Awesome! Awesome. Yeah, not bad. Okay, so that's, I think, pretty cool. I think with that, what I think I want to do is, I think I'm going to end the show, because Roy, my friend Roy's not here, and and the next step we have is going to be, we're going to be dealing with velocities and moving and changing the particles. But the essence of it, I think, is not bad, right? We're not bad. We're sort of a good starting point. So on tomorrow's show, what I want to do is I want to have these particles flying through space and also coming out as they're flying through space as well. And also be able to vary based on hue, not just the size, and also work on giving it a lifetime as well so the particles fade out and clean themselves up as well. So with that, let's give away a copy of CodeRushed.
CodeRushed giveaway!
That's right, it's time for a CodeRushed giveaway. And today's winner is
Clock Tower.
Clock Tower. All right, congratulations, Clock Tower. You've won a copy of CodeRushed. I will DM you after the show and get you instructions for that. I want to say thanks to everybody out there in the chat room. Will, as usual, it's always awesome having you here in the show. And everybody else, thank you. So we have done not too bad on the particle emitter. By the way, I will be at VS Live in Vegas in March, about 3 months away from now. I'll be talking about the science of great UI and design there. So I've got some sessions there. So so excellent. We'll do that. And so thanks a lot for everybody. We will see you tomorrow.